Hey guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have this problem k smallest in lexicographical order, and this problem tagged as an hard, and the maths involved to solve it is indeed an hard problem for sure. Right? So what they have given to us, the problem is just a one-liner. So given two integers n and k, return the kth lexicographically smallest integer in the range of 1 to n. In the range of 1 to n, I think we have already discussed the lexicographically smallest integer in just of yesterday's video. So I am assuming you guys know. So if I am going to consider after 1 who is going to be lexicographical smaller, then as in number theory, after 1 we should going to get 2, right? But here you can see after 1 we are going to get 10, because in 10 the first digit is 1 and on 2 the first digit is 2. So which one is smaller? 1 is smaller. So like this way the lexicographical order should be same, and we have to return the kth smallest of them. So the second smallest number is 10. On this case, after 1 we got 10. Now for n equals to 1, k equals to 1, the output is 1. And here you can see, so the problem is hard because only for the constant reasons. Otherwise it should be a like medium or a kind of easy medium kind of problems. Only the constant make it as a like different difficulty level. So here you can see your n can be as big as 10 raised to the power 9, and k is bound to be within the range of 1 to n only. So now, without wasting any time, let's quickly go to our OneNote. So now there are steps involved to solve this particular problems. There is like no alternate. You can like disobey that and then you are going to get a AC. That is never going to be happen. So there is for sure a steps is involved. There are predefined steps involved to solve such kind of problems. So you kind of need to remember the steps, or like defining to an interview. It's kind of an indeed hard, like on interview times, to define this such things. So there are few things, like if I am going to start, am I able to write it? Click. So I now should be. So if I am going to start to generate the number, so if I am going to try to generate the number, so first lexicographically smaller is 1. So the most significant digit, that is of 1. So for them we have yesterday discussed. For them we have 1 to 9 opportunity. For that we have 1 to 9 opportunity, and for rest all the places, we have opportunities from 0 to 9. I think these two things you remembered from yesterday's video. So first place is going to be occupied by 1 to 9. Now for second place, we either have a 0, or we either have a 1, or we either have a 2. Like this way we have multiple. And for next one is going to be 2. So and like this way, for 0 again we have choices for 0, 1, 2, like this way, dot 9. So for every node we have opportunity from 0 to 9. So now if I am going to explore all the possibilities, if I am going to explore like between, let's suppose our kth smallest lexicographically orders lies with starting from node 2, starting from most significant bit, starting from 2. Then if I am going to go to visit these like generate all of them like this way, if I am going to generate all of them, then the time complexity is going to be for sure of, there is no excuse we can get rid of. The time complexity to generate this is going to take a big of n, and our constant can grow as big as 10 raised to the power 9, and we know, so that is greater than of our 10 raised to the power 8. So it is going to give you a TLE. So we can't go to visit all of them. So no we can't do. So by some mathematics we have to say how many numbers starting with 1 of this particular n value, for this particular n value, how many numbers starting from 1 and we starting like between the gap. So I am interested between the gap between starting from 1 and starting from 2. How many numbers, how many childs of the entire subtree or the entire tree of 1, starting from the most significant bit as 1, how many numbers we have it, so that like after that we are going to start our counting from most significant digits as 2. So how many nodes we have it. So if we can going to calculate that. So for this if I am just going to take two nodes. So let's suppose, so let's consider one by one. So for 1, the next number is going to be 0. So here it is 10. If I am going to write it 10, so for 2 also it is going to be 20. So now if I am going to check what is the what is the difference? What is the difference between node starting from 1 and starting from 2? So what is the delta here? What is the delta here? Can I write it? It's 1. What is the delta on this particular place? Can I write it? It's 10. Similarly, if I am going to go more depth, if I am going to get at 100, so this becomes 200. So let's take a boundary. Our n, let's suppose 986, something like this, right? Let's suppose our n is 986, or let's take a smaller value so that it can be easier to show the diagrammatical format. So and our k, let's suppose is also 286 for let's suppose this. So I am pretty sure that my answer is on this particular case is 286 for sure. 286 for sure. So after this, if I am going to make a jump to 1000, to make a jump of 1000, and it becomes 2000, right? So this is not more than my tell me guys, more than my tell me guys, more than my n value. So no, this jumps is not allowed. So returned, right? These things we have to do. So what is the gap here? What is the gap here? It's nothing but 100. So what is the total gap then? 1 plus 10 plus 100, that is nothing but 111. So that is the gap. So that many numbers we are bound to get starting from 1 to all its entire subtree. So now we are sure that what is our k value? Our k value is 286. So our k value is 286. So if I am going to start my current, where should I start our current? 2b1. So how many numbers? So we are in our current. So how many numbers we need to skip? So k basically standings the 286th number. So I am at the first number. So my k value should be minus equals to 1, right? Because that many most numbers. So let's suppose they are looking for the first number. Then my k's value becomes k, if the k is 1. So on that case k minus 1 is 1. So when k is 0, then our job is done. So that is the base case. When our k is 0, whatever the current we have at, return it. Return current, right? We can directly return our current itself. Agree? Totally agreeing, guys. So now let's consider our k is at 286 only. Our k is at 286 only. Now let's define how we can skip and find the number. Now I know my 111th number has skipped. My 111th, these many numbers have skipped. So how much? So how much we have to reduce our k? That is the skip. That is of, there can be two cases. If my steps, if I can write you, if my steps, that is this many numbers, this many steps we have already gone. If my steps is less than equals to my k, if I can write it, if my steps is less than equals to k, then do a steps minus equals to, k minus equals to my steps. So that many steps we have already covered. And I have started with my current equals to 1. That is the most significant bit as 1. Then my current should go to plus. So current is now 2. Now continue. Now we are at this particular node. Right? So my current is 2. Again, we have to check. We have to check between this 2 and the third one is 3. Right? 2, 3. What is the delta? 1. Move ahead. 20, 30. What is the delta here? 10. 200. This is 200, and that is going to be a 300. So that is exit. So there can be possibility my next prefix or the most significant or the start 2. So we have pointed our start 1 here, and our start 2 here, start 2 here. So if that is the case, my start 2 is exceeding, but start 1 within the range of the 10th multiplication. On the 10th multiplication, then I will take the gap. How I will take the gap? I will going to take the gap to be min of, who is the minimum between my n plus 1, because the n1 is inclusive. To make it inclusive, we have to have a at plus 1 and the minimum of my home start 2, right? And I have to take minus of start 1. So that is the steps I am able to cover. So I will add my steps to be that many steps. I am going to add my steps to that many steps. Agree, guys? Totally agree. So for 300 it is so the minimum is 286 plus 1, that is of 287 minus, because if it is 300 is exceeding, right, n plus 1 is smaller, then on that case we have to take the minimum, because that is not liable, because if my start 2 is going to be higher and my start 1 is within the range, then we have to take my start n plus 1 only, because n plus 1 is my last boundary. Why n plus 1? Because we have to find the gap inclusive n. So that's the reason we have to do a n plus 1. And 287 minus my first one is at 200. So what is the gap here? 87, right? Agree, guys? Now the next jump stage is bound to be make it also out of boundary. So return. So for 200, so what is the steps we got? So 87 from here, 10 for between 20, 30, and plus 1 is at 2, 3. So how many? 87, 97, 98. And what is our k value? So we have done our k to be at 286. So our k was previously we have start with 285, because we have start to k minus equals to 1, because we have start with 1. So 285 minus 111 that we initially did. So this becomes 1, 2, 3, 4, 5, 4, and this one 7, 1, 2, 174, right? Agree, guys? So we have initially 174 and 174, and what is the steps count we got? Here? So we have 174. So 286, 285, 100, 110, 111s. Yes, right? So our steps count was 174, and here we got. Let me quickly check it out once. So calculate steps while start 1 less than equals to n. So till my start 1 less than equals to n, I am going. So I got a gap of here. I took 287. No, I think I did a mistake. So the checks should be between 2, 3. Next checks should be 20, 30. Next check should be 200, 280. 280 n plus 1 is 287. 287. Next it is going to be out of bounds. So from here it is 1, here it is 10, and from here it is 87. It is 97, 98 we got, and it is also seems to be my smaller than. So what was our earlier checks? If my steps is less than equals to k, what is my k value? My k value after that is 174. So k is 174, and my steps here I got it as an what I got it here? I got it here as a 97, right? 97. If I did everything, sorry, not 97, 97 plus 1, 98. The steps I got here is 98. So it is still closer. So it is still close. So 2 also we can skip. So if my k is greater than equals to my steps, then what we are doing? K minus equals to steps, and I am doing to current to be to 3, third boundary, right? So I am now going to iterate to 3 only. Yes, agree, guys? Totally agree. So and on that particular case, my k minus steps is going to be what it was earlier, 174 minus 98. So how much it is? 6 to 9, 16, 76, I guess. 76. Yes, it's indeed 76 only. So now we have branched out one more. So we have now one to check between. So there is one more branch we have incorporated between to check the delta between 3, 4 gap is 1. 30, 40 gap is 10. See, guys, so these things 300, 400 both are out of boundary, not going to be checked. So what is this? So we got only 3, 4, 30, 40, right? 3, 4, 30, 40. If I am going to draw the tree again, so 1 done. So now I am going to write only 3, 4 ones, right? Because others we have already validated. There is answer not exist for 1 and 2. So we check 3, 4, then we go for 30, and here also we go for 40. Still within the range. 300, 400, no use, greater than my n. So the gap is we got here is 1 plus 10, that is of 11. So now we got a gap of what it is 11, and my k was, what is my k value? I steps got I at 11, and what is my k value? Tell me quickly. It's 76. Yes, it's indeed smaller. I can do a minus of how? 76 minus 11, that is of 66, 65. My k becomes 65, and my current becomes 4. Now we have to check between, tell me guys, now I have to check between 4, 5, right? See guys how I am skipping. So I have done with all the threes. All the threes I have done, all the ones I have done, all the twos I have done. So 4, 5. Yes, indeed within the range. 40, 50. Okay, go for it. 400, 500 out of bound. So here also minus 11. So like this. After this, k becomes 65 minus 11 is, tell me, 54. Current becomes 5. Yes, current becomes 5. Now 5, 6, 50, 60. Right? Again 11. K becomes, tell me. See, focus on this particular iterations or the intuitions, how this algo is working actually. What is the delta? Tell me. Minus 11, that is of 43. Count becomes 6. Yes. 6, 7, 60, 70. 11. K becomes minus 11, that is of 32. Current becomes 7. Now again 7, 8, 70, 80. 7, 8, 70, 80. Right? Delta is how much? Delta is how much? Tell me guys, delta is how much? Delta is 11. K becomes, where we left, 32, 21. Current becomes 8. Yes, current becomes 8. Now 8, 9, 80, 90. K becomes 21 minus 11, 10. Current becomes 9. Now what is the next? So after 9, do we have anyone starting from like post that? My this the k becomes 10. My k becomes now 10 only. My k becomes is 10 only. Right? Now after 9, whom should I have to consider? Like my current plus 1 is going to be okay, let me think on this. Like this one is 9. My next note, if I am going to consider this of 10, I am not able to consider. 10 I am not able to consider, right? So what I can do, let's do it. Let me think about that. 9, 10, gap is 1. If I am doing so, let me think about this. This is of 1. Then the next one becomes 90, 100. 90, 10 plus 10 is 100. 90, and here also we got 100. 90, 100. So for 90 and 100, what it is considering to be, then here we got a gap of 10. So 10 plus 1 is 11. So but here it is the first case where my if of current, my steps, if I am going to get a steps of 11 only, if my steps is less than equals to my k, right? So that is the reverse case. If my steps is now higher than k, then what I can do, if my steps is higher, right? On this particular case, if my steps is becomes higher, then on that particular case, what should we have to think of? I should go to more depth. And my k becomes, because I am going to depth only, right? I'm going to depth only because I'm not going to consider this. So we have started with 9. So our k becomes minus equals to 1 because we have considered 9 to be a starting one, and my current becomes how far my current should increase. So my current becomes current into equals to 10. So now I have to go to depth, because for 10 it is not an indeed valid. So we have just do to do the comparisons, right guys? So now we go to 90. Yes, now we at 90, and my k becomes how much? K has decreased just by once. So see guys, now the beauty, k becomes 1. We have just able to decrease it by 1. So k becomes 9 and my current becomes 90 and my current becomes 90. So now if I can quickly draw the diagrams, if I can quickly draw the diagram. So now for this, now we are at 90, right? So there can be 9. So on 9 we have decided to go to 90 and now we have to check. I am always taking current and to current plus 1. 9 and 90. Delta is 1. Okay, fine. 90 into 10. 900. 910. Invalid. No go. So now my steps. What is the steps? What is the steps count here is only one. Now see. My steps count. What is the steps count we got here? Step count we got here? So now steps we got as 1. And what is my k value? My k value is currently at, what was the k value? Tell me guys. K is nothing but, on 10 k becomes 9, no? K becomes 9. So my k is higher, right? So if k is higher, if my k greater than equals to my steps, then we can do a k minus equals to steps, and we can increase our current. So current becomes current plus. So from 90 we go to 91. Now do the comparisons. Again there can be 9. Now we are at 91 and it is going to compare with 92. It is going to be compared with 92. Yes, 91, 92. And my k after this, k minus steps, only one steps we are able to identify. My k becomes 8, right? K becomes 8. So 91, 92. Again only one. So k becomes 7. Current becomes 92. Then again k becomes 6. Current becomes 93. K becomes 5. This becomes 94. 4, 95. 3, tell me, 96. 2. Yes. 2, 97. 3, not 3, sorry. 2, then 1, right? 1. Above 1 is decreasing, right? 97. This becomes 98. Yes, 98, right? 98. Then this becomes 1 to 0. 98 becomes 99. So when my k becomes 0, I got my answer. So on this particular case, on this particular example test case, the answer should be 99. If we can quickly run it, this. So if I'm going to consider a case where my n is 286 and I am looking for the very last one, that is of 286 one only. So what is the output? On case 3, yes, see guys, it is giving 99. So like this way, it is going to go to the depth. So this is the arbitrary test case that I have taken in very arbitrarily to discuss, but yeah, like we are able to successfully do the skipping. Now quickly do the code iteration. So that's the intuitions. I have discussed the intuitions. The code is going to be very simple. So we have to run these loops while we have this k value, while our k is non-zero, then we have to do to calculate our steps. So we call our calculate steps functions by start 1 to be current and start 2 we are taking to current plus 1, right? We already take them, and steps to be 0. See guys, this is the initializations. Current I am initializing to be 1, and I already told that my k to be minus equals to 1 because I am starting from 1, and 1 numbers I have already skipped. So that's the reason. So I am starting with current equals to 1, k should be minus equals to 1 on that particular time itself. And if so, now see the functions, calculate steps to be 0. When my start 1 is less than equals to n, I have to iterate. My steps should be plus equals to minimum of these things, n plus 1 and start 2 minus of start 1. Already discussed these things, and we always have to go to the next go by multiplying both start 1 to be 10, start 2 to be 10, start 1 to be 10, start 2 to be 10. So I did exactly same things, and finally after this my steps is already updated. How many numbers exist between this current and current plus 1, that is of start 1 and start 2, starting with that number and start 2 to that particular numbers, and there is the delta of exactly of plus 1 between them. So the steps is holding this, Now if my k is greater than my steps, negate out that many steps, because that many steps I have blindly skipped because my answer is not exist there, and we can go to current plus 1. And else I have to go to depth. I have to go to depth. So I can decrease my k to be just equals to -1 because only just one numbers I have skipped to go to the depth, and the depth should be what is the current number into 10. What is the current number into 10? So that is actually the beauty, guys. That is actually the beauty for this particular problems. And finally we can return the current. Finally we can return the current. Yes, guys. So that is all about the time. That is all about the code iterations and the intuitions building part. And now we can quickly discuss the time complexity. Now, I guess you guys should predict on your own the time complexity. I think time complexity should be of big of log n only, log n base 10 only, because we are going to go to the depth only. We are going to go to the depth only, right? We are always going to go to the depth only. Server is busy. Why? When I am going to ask them, the server is always coming to be busy. So here you can see we are going to depth. We are going to go to the depth of every time. So it is of big of log n, and these functions on this particular functions also we are going to go to depth. Here also we are going to go to depth. So on k loop, while k, so this k is going to be decreased by that many steps. So there is a logarithmic factor, and this calculate steps functions is again going to be a taking of another logarithmic factors inside a log factor. So that's the reason the time complexity is big of log n raised to the power 2. Yes, log n raised to the power 2. That is the time complexity. Log n raised to the power 2. And space complexity. Do you guys see we are using any extra space? Do you guys are able to see? No. That is a big of 1 for sure. That is a big of 1 for sure. Maybe we can check. Yes, it is of big of 1. It is of big of 1. So yes, guys, so that is the most optimized time and space complexity you can achieve for this particular problems, and you can see our submissions is altogether 100% faster than all over the submissions over the Leetcode, and it is indeed to be the most optimized submissions. And I know this particular problems is kind of a extreme difficult level problems. The maths that has the hidden maths that we have to incorporate to skip the numbers between like current and current plus 1, they are actually the maths evolved. So I personally feel it is a kind of indeed hard difficulty problems, and if you are super unlucky, then only you are going to get this kind of problems for interview. And if you guys are able to understand, so I have tried my best to explain to you guys, and if you guys are able to understand till this point, so I guess you guys are already doing so. Please do subscribe to our channel, and please share the videos to your friends circle who are also preparing for top database company and brushing up their TSSs. And please turn on the notifications so that when we are going to get to our next video, you guys are going to get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.